Welcome to this lecture. In this lecture, I will discuss a problem on initial value theorem and final value theorem of Laplace transform. The first problem is verify the initial value theorem for the signal x of t equals to 4 minus 2 into e power minus 3. So we will see the solution of this problem. So first let me write the expression for initial value theorem. So initial value theorem says that limit t tends to 0 x of t equals to limit s tends to infinity s into x of s. So this left half part is, so we call it as LHS. So this second part, right side part is we call RHS. So in this case, so we'll find the value of LHS first, then we find the RHS. So finally we compare these two values. If these two values are equal, then we can say the initial value theorem is verified for the given signal x of t. Suppose these two values are not equal, then we can say the initial value theorem is not verified for the particular signal x of t. So we'll find LHS first. LHS equals to limit t tends to 0 x of t. So limit t tends to 0. So x of t is the signal given as 4 minus 2 into e power minus 3. So after substituting t is 0, so in this expression, so we'll get 4 minus 2 into e power 0. So that equals to 4 minus 2 e power 0 value is 1. So that will get 2. So limit t tends to 0, x of t value is 2. So now we'll come to the RHS. So RHS equals to limit s tends to infinity s into x of s. So we know that x of s is Laplace transform of x of t. So that equals to limit s tends to infinity s into x of s. So in place of x of s, we write the Laplace transform of x of t. So that equals to limit s tends to infinity s into the Laplace transform of signal 4 minus 2 into e power minus 3. So this is a causal signal or right-sided signal. So then we can write into u of t. So this equals to limit s tends to infinity s into Laplace transform of 4 into u of t minus Laplace transform of 2 into e power minus 3 into u of t. And this is all we put in a bracket. So limit s tends to infinity s into, so Laplace transform of 4 into u of t. So Laplace transform of u of t is 1 by s. So 4 into 1 by s, so we can write it as 4 by s minus Laplace transform of 2 into e power minus 3t. So Laplace transform of e power minus at is Laplace transform of e power minus at equals to 1 by s plus a. So 2 into 1 by s plus, in the place of a we have 3, so 1 by s plus 3. So now multiply s inside the term, limit s tends to infinity, so we'll get 4 by s into s, so that becomes 4, s becomes cancelled, minus 2 into s by, in the denominator we take s is common, then we'll get 1 plus 3 by s. So that equals to, so here s become cancelled. Now we can apply the limit s is infinity. So inside the function, so we'll get 4 minus 2 by 1 plus 3 by s. So 3 by infinity. So that will get 0. So that equals to 4 by 4 minus 2 by 1. So that is 2. So equals to 2. So this is RHS, right, part of this expression. Now compare the left half side LHS value and RHS value. So in this case, so LHS equals to RHS. Therefore, we can say the initial value theorem is verified. As a second problem, we see verify the final value theorem for the signal x of t equals to 3 minus e power minus 2t. The solution to this problem, so first, as we did in the previous case, we write the initial final value theorem of Laplace transform. So limit t tends to infinity, x of t equals to limit s tends to 0, s into x of s. So we find the LHS first, left half part, and then we find the right half part of this expression, and we compare these two values. If these two values are equal, then we say the final value theorem is verified for the signal x of t. So LHS equals to limit t tends to infinity, x of t equals to limit t tends to infinity. So x of t signal is given as 3 minus e power minus 2t. So that equals to 3. Now apply the infinity value in the place of t. So we can write e power minus infinity. So e power minus infinity value is 0. So we write its value is equal to 3. So limit t tends to infinity, x of t is equal to 3. So this is nothing but LHS of the expression. So now we will try to find RHS value. RHS equals to limit s tends to 0, s into x of s. So that equals to limit s tends to 0, s into x of s is nothing but Laplace transform of x of t. So that equals to limit s tends to 0, s into Laplace transform of 3 minus e power minus 2t. So this is a causal signal. So we can write into u of t. So that equals to limit s tends to 0. So s into Laplace transform of 3 into u of t. So we write 3 by s minus Laplace transform of e power minus at. It is in the form of e power minus at. So that we can write 1 by s plus a, s plus 2. In the position of a, we have a 2. So that we can write. So limit s tends to 0. So we multiply s inside this. So we'll get 3 here minus s by s plus 2. Now we apply 0 in the place of a. So we'll get 3 minus 0. So its value is equal to 3. So this is nothing but RHS, or we can also say it is limit s tends to 0 s into x of s. So now observe this LHS part and RHS part. So in this case LHS equals to RHS. Therefore we can say final value theorem final value theorem is verified for the signal x of t. Thank you.